So my presentation is focused on the fueling and energy costs that we have from the fleets that we've been working with. So I work for the National Renewable Energy Lab, and if you're not familiar with that, it's one of the Department of Energy's national laboratories that's focused on energy efficiency and renewable energy. And the work that I do is more of third-party validation. We work with transit fleets and soon to be some truck fleets on looking at how these buses work in real-world environments and comparing them to both the technical targets that were set by FTA and DOE, and also to conventional vehicles in the same service. So we have an established evaluation protocol that we use for all of these evaluations, so everything is pretty standard. If you look at any of our reports, you can see very similar data metrics across all of those evaluations. We provide that feedback to the government as well as to the transit fleets and the OEMs that are the partners that are installing the technology in the different fleets. And we share this information back with the transit agency. The idea is that you can learn from their early experiences. So we try to document that. This chart, I don't know how well you can see it from out there, but this shows the fleets that we have been and are in some cases currently working with. Over time, we've collected data on a number of fleets. Many of them were hydrogen fuel cell buses, and we're also collecting data on electric buses. And so the colors are for the technology, sort of a fuel cell dominant in green. We've got the newer buses seem to be more of a battery dominant fuel cell. And then we've got some fast charge battery electric buses that we've worked with, as well as the plug-in buses, some of which we have data on and others we are just starting to collect data on. And the evaluation, the money that we get is funded through a number of different sources. We get funding from DOE for most of our fuel cell products. And then we work with FTA funding for fuel cell and electric. And then Air Resources Board has given us money for some of our electric bus projects. So first I'm going to talk about the fuel cell fleets. We're going to talk about hydrogen costs. The focus of this is what is it costing these fleets to fuel or to charge their buses. And there's a challenge in comparing them because we've got different fleets, different operations, and also different infrastructure setup. So this chart shows you the 4 fleets that we're going to talk about for hydrogen fuel cells. 3 of those are here in California, and most of them have people here. So if you have some questions on details from these, you can ask the fleet partners themselves. So we've been working with AC Transit for a number of years, and Sunline Transit Agency as well. We've got some data here from Orange County Transportation Authority and also SARTA, which is in Canton, Ohio. So we do have one fleet that's outside of the state of California. And this chart just shows how many buses, the size, the type of bus, the data period that this includes. And I mentioned the different types of infrastructure. So for AC Transit, they have 2 stations. They are liquid delivery with some electrolysis. The Sunline, the data that we have is from their older station, which is steam methane reforming, and they own and operate that station themselves. They've got a new station going in, but we have not gotten any data on that yet. For OCTA, their situation is different. They're building the station. We heard about that from Trillium this morning. But what we have is, while they didn't have a station, they've had to fuel at retail locations, which is, it's good that they have retail locations, but you'll see what that means when we look at cost for them. And SARTA has their own station, and it's liquid hydrogen delivery. So this chart shows you the summary of the data from each of those fleets. And I mentioned the different situations as far as hydrogen. So there's some caveats to this. With the hydrogen, it's not exactly an apples to apples because their stations are different. For AC Transit and SARTA, it's pretty much the cost of their hydrogen for liquid delivery. It does not include operation and maintenance cost. For Sunline, since they own and operate that station, it does include O&M. And their cost I've seen swing from as high as, $58 a kilogram or 26 for this data period, down to $2 and something, depending on how much work they had to do on the station. For OCTA, I mentioned that they were fueling at retail stations, so they might have costs as low as $12 or $13 a kilogram, or as high as $16, $17 a kilogram, which is not going to work for most transit fleets. And then, so this gives you the data period, the number of months that includes, the high and low and the average cost we see per kilogram of hydrogen. And then the orange is the baseline for each of those fleets. So for AC Transit, we had diesel baseline. For Sunline and OCTA, their baselines were CNG buses because they don't operate any diesel buses. And then for SARTA, we had some CNG buses and some hybrid buses that they had. Their hybrid buses were very old, so the main combination is with the CNG buses. So you can see the overall fuel cost in dollars per mile is still much higher for hydrogen buses because of that fuel cost. So the main comparison would be between the two lines that we have, that I have outlined in the bars with the baseline cost per mile for that operation versus the hydrogen cost per mile. So first I wanted to talk about the fuel economy difference. So for each of these agencies, we have a chart that shows the fuel economy in diesel gallon equivalent. So even the CNGs I've converted to all diesel gallon equivalent, so it's easy to understand the comparison. So you've got the average, you can see over time, both the baseline and the fuel cell buses, and then with SARTA, you can also see the hybrid buses. You can see that the fuel cells are more efficient. They do have a better fuel economy. We have seen some drop over time. Someone asked about degradation. It usually typically shows up in the fuel economy numbers dropping over time. So some of that is degradation, some of it is changes in use of the vehicle, because we all know that the way you use the vehicle, this duty cycle is affects the fuel economy quite a bit. So you can see that for all of our fleets, the fuel cells have been more efficient than the baseline fleet. But when you compare the cost per mile, this is when the comparison doesn't always look quite as good as we'd like to see. And you can tell for Sunline, you see how much of a variation their monthly cost per mile is, and that's because it does include O&M. So if there's issues with the station, or they didn't operate it very much because they had problems and it wasn't that many kilograms, then your cost per mile, the miles for the buses will be lower, the cost will be higher, so the cost per mile will be quite a bit. For the fleets like SARTA and AC Transit, with a fuel provider that works closely with them, they get more of a long-term fuel price. It might shift some, but it's not drastic. So their cost per mile is pretty even over time. And I mentioned OCTA having to do retail cost is pretty challenging, because that definitely throws those costs up much higher than the others. So some of the things that we thought of, CARB wanted to talk about what agencies could do to try to lower those costs. And some of that would just be volume. And I know DOE's target for hydrogen cost is around $4 per kilogram. And we aren't quite seeing that yet. And but as mentioned before, the capital cost for getting a station for hydrogen is challenging up front, because you have to have that capital cost. But with increasing fleet size, we think that cost will go down. Getting those stations scaled up is easier for hydrogen, I believe. You can have more storage on site, more frequent deliveries, add dispensers, and that makes it a little easier to scale up with cost, with fleet size, even though that capital cost is quite a bit at the beginning. So working with your fuel provider, and we've heard that before, working with the fuel provider early on can help with those costs. And then the source of the hydrogen, of course, affects cost. If you have to have renewables, it might be more than right now. Steam methane reforming is probably the cheapest, but it's not necessarily the ideal situation depending on where you are. So turnkey situations where you work with the provider and they might own and operate a portion or all of the station can help with those stabilizing those costs, and also long-term fuel contracts. We would expect to do that. Station utilization, so higher volumes, you might get better rates with higher volumes of per unit cost might be lower. And then for all buses, really maximizing the efficiency. So maybe you train your drivers to have a better efficiency, but that can be more of a challenge than it's worth, especially if you have a really high driver turnover. Switching the gears and talk about the battery electric bus fleets that we've worked with over the past few years. So the data I'm going to show you come from three different fleets. So we worked with King County Metro in Seattle for, we have a year's worth of data on those buses. And they had on-route fast charging buses by Proterra. Then Foothill, we've been working with them for a number of years with the data that I'm going to show you is from their 35-foot fast charge bus fleet. And then we worked with County Connection, and they have a trolley replica that was a Gillig bus with a BAE electric drive system. And they plug the buses in overnight, but they also have inductive charger en route, and they stop at that charger every circle. It's a circulator, really slow circulator route. So this shows the different buses, and we'll talk about the data from those. So here's the electric cost summary. And with electric, because the way the electric utilities this comparison is more of an apples to apples than what we saw for hydrogen. Everybody gets their electricity pretty much the same way, just from a different provider. So that per kilowatt hour just depends on where you are, and I guess the source. There's probably a lot of different things that go into that. I'm certainly not a utility expert. But this shows the data from Foothill, County Connection, and King County Metro. And you can see that their cost per kilowatt hour, their summer rates and winter rates are typically different, so that's why I showed each of those rather than the high and low. The summer rates are typically higher than what we see, and then I give the overall average cost per kilowatt hour for each of those fleets. And then once again, the combination between the baseline is in orange, and the blue is the battery electric buses. You can see for those we had Foothill and has a CNG baseline, and County Connection we used a trolley replica that was the same size. It was an older bus, but we looked back at the fuel economy and it didn't really change drastically, so we've used that data as a more apples to apples in the same route service for comparison. And then for King County Metro, we actually had 3 different baseline comparisons. We looked at their trolley buses. We also looked at some brand new diesel buses, and we had some new diesel hybrids that we compared those to. The numbers that I show on there are the cost per mile for the hybrid and the diesel bus. So you can see that the cost per mile is still higher for the electric buses than what we're seeing for the baseline buses. So this chart shows you the fuel economy for the battery electric buses compared to their baselines. It might be kind of hard to see from up there, but the main thing to look at is the difference. The electric buses, and this is all still in diesel gallon equivalent. So you can see that the electric buses are, they mentioned earlier, 3 or 4 times higher than the efficiency that you see for the diesel or the CNG buses. And so over time, might see some fluctuation, and some of that would be, they talked about accessory loads, air conditioner, heat loads, they make that fluctuate, whereas the CNG and diesel buses tend to be, you might see a little fluctuation, but it's not typically as much as what you see for the battery electric buses. So despite this really high fuel economy in diesel equivalent, when you look at the energy cost data in dollars per mile, you see a lot more fluctuation, and it's still higher cost when you compare that to what most fleets are paying for their diesel or their CNG. Right now, CNG costs are really low, and most of our fleets that have diesel buses have locked in some fairly low cost from $1.50 to $2.50, which doesn't compare that favorably when you look at the battery electric buses. But knowing what it's going to do ahead of time can certainly help to manage those costs. And the fluctuation that you see is typically because of the difference in rates between summer and winter. So you'll see the higher cost per mile in the summer when those rates are higher than what you see in the winter when your rates are lower. Then one of the things that they've talked about is understanding your what you need to understand for managing cost for electric buses, and you need to understand what your utility rates look like. It's really good that we're seeing so many of the utility providers come forward and look at how they can come up with special rates for EVs, because they want to see more EVs in service. And so I've got a couple of charts here that show what this is each month it's the breakdown of the electric bill and on a cost per kilowatt by what part of the bill is the makeup. So in some cases you've got a tier 1 or a tier 2 or tier 3 charge, and then you've got demand charges, and then you've got your fees and taxes and things like that, which is typically the same as from one month to the next, but you can see the difference. Now, the long chart at the top is the one for Foothill Transit. And when they first put those buses in service, they got some breaks on the rate. And so you see about halfway through that rate changes. So the early rate didn't really have demand charges. But in the meantime, Edison was working on some new EV rates, and they allowed, Foothill was able to move on to one of those special EV rates. And you can see that while the total cost per kilowatt hour didn't change drastically, the makeup did. So after that, you can see that red was their demand charge, which makes up a good portion of the bill. The lower chart is a similar chart for one of the other fleets, and you can see in that case the gold is the demand charge, and you can see that their base rates are about the same, and then the demand chart kind of varies and causes that cost per kilowatt hour to go up and down depending on that month's charge. Other infrastructure considerations, and some of the things that I'm mentioning we've heard already, and I'm sure we'll hear a lot more details on how to mitigate those costs. But as we heard earlier, the infrastructure for BEVs is pretty easy in the beginning when you only have a handful of buses, maybe a few chargers. It's not that challenging to start out with electric buses, but it's more challenging to scale up. And I think it's complicated, and I think transit agencies need to work closely with their partners to see how they can best do that. Because you might need electrical upgrades. If you've got 250 buses at a site, that's going to be challenging to figure out how you can easily scale up and have enough power to meet your needs. Also, your depot space, wherever you put those chargers, you have to worry about logistics. With a fuel cell bus, they're fueling similar to a diesel, but with the electric buses, you need to think about logistics of moving through the yard, especially if you put chargers out where you normally just have parking spaces. So you have to have more room and figure out how best to move through that process. So it might change the traffic flow. And then also manpower. You have to think about plugging and unplugging the buses. Maybe you have it set up so that you plug them all in, but if you have fewer chargers, maybe you have to have somebody go out in the middle of the night and change that charger. So that's something that has to be thought about, how you can minimize that extra charge. Then they mentioned earlier working with your utility, like starting yesterday, and I think that's really important because they are very valuable partners in helping to mitigate and plan for those costs. Then there are smart charging solutions out there. I think some of them are just being evolved, and that they will get better with time, but you need to think about how you might delay your charging to avoid those peak electric rates, manage your bus charging, and that of course requires a sufficient window of time to charge all the buses. If you're not charging them all at once, maybe you're doing 4 at a time, you've got to have a big enough window so that you can get all those buses fully charged before they're ready for service the next day. And then maybe there are some software programs out that might sync the bus with the actual route that you're planning to run it on. So maybe you've got a bus planned for a route that doesn't take a full 150 miles. Maybe it only goes for 80 miles. So maybe you don't need to charge it completely for that day, and that might help mitigate some of those charges. And as I mentioned with the fuel cell buses, having the drivers learn how to best drive those buses for most efficiency can definitely help mitigate those costs over time. Delay with this thing. And then one of the things that we talked about is with fleets that have not done this before, they don't really know how to get started, and maybe they want to try it before they buy it. Well, most of the, maybe you should consider doing that, try before you buy. Most of the manufacturers, and this is not an all-inclusive list, it's ones that I know for sure are willing to bring out a demonstration bus and give you a try and let your bus drivers drive it and put it in your service. So that's one way to find out if those buses might be right for you or you're comfortable with operating them. And then also, SARTA in Ohio has a number of fuel cell buses, and they've got a borrow a bus program. And I don't know if you guys have heard about that, but they've got a list of transit agencies that are interested in fuel cell electric buses. And so they've got a short-term borrow the bus, and the manufacturers are supporting that with infrastructure. So they'll help with the fueling infrastructure and support for any work on that on those buses while you borrow those for a period of time to see if the hydrogen fuel cells work for you. I do have the link to that site where you can get more information and find the right contact person if you're interested in borrowing one of their buses for a demonstration. And that was the end of my presentation, so I'm willing to take questions if anybody has any. Yes, do we need?
Hi, Leslie. Ray Pingle from Sierra Club, California. And first of all, really appreciate all the work you and NREL have done on these longitudinal studies. I think they're very helpful. The question I have is, when you're looking at the fuel cost, did you consider it part of the scope of NREL's analysis to also show the net cost of electricity per mile, net of LCSF credits?
That's not part of our evaluation. There are other people at NREL that do some other evaluations that are outside the scope of what we've been funded to do, but no, we have not done that.
I know you probably don't have the data, but interested to know how SARTA made it through the polar vortex and trying to heat. Because a battery electric bus trying to operate in those cold temperatures is never going to make it. In fact, I've heard of some of the stuff in Minnesota having diesel-fired heaters retrofitted on battery electric buses.
They didn't retrofit them; they bought them that way, and we're going to be doing Duluth. We kicked that one off pretty soon.
Duluth was the one.
Yeah, Duluth, and they have fuel-fired heaters. We're going to collect data on those heaters as well. Yeah, it's a challenge for battery electric buses. They don't have that extra heat and that is the biggest draw on the system from what we understand, what we've seen in our data. So we will have cold weather climate. We'll have Duluth, and we're also going to work with SEPTA, so that will give us Philadelphia's climate as well. The fuel cell buses have had issues in the past with heat, but I don't think it's quite as bad as what we've seen with the battery electric buses. But I have heard, I know that when we worked with the fleet in Connecticut, there were some complaints about the buses not being quite warm enough, but they were fuel cell buses and not electric buses.
When the polar vortex hit a couple of weeks ago, it was miserable.
I haven't gotten the data from that time period at Duluth yet, but I'm sure we'll see that.
Yeah, but SARTA would have the fuel cell data eventually, and you don't have that yet. It just happened a couple of weeks ago.
Yeah, we have data through December from SARTA.
It'd be interesting to know those numbers.
Please do speak into the microphone so people watching the webcast can hear you.
Just to clarify, the buses for Duluth,
yes,
the heaters were always part of the build?
Yes, that's my understanding. It was part of the cold weather package.
Ed had mentioned that they were retrofitted?
Not to my knowledge. They were part of the original build.
That was part of the bill of materials from the beginning.
Right. They knew that was going to be a challenge for them, and so they elected for the cold weather package with the fuel-fired heater.
Yeah, Jamie Levin with CTE. So first of all, Leslie, all the work that you've been doing over many years, and I've been working with Leslie since the early 2000s, to give credibility to this advancing technology has been fantastic. But to answer Ed's vortex question, in the New Flyer bus that we are just now beginning to commission, the New Flyer fuel cell bus, New Flyer's actually tested that in minus 20, or 20 degrees, not minus, 20 degrees Fahrenheit. And because the Ballard fuel cell puts out exhaust heat, we're using that exhaust heat to actually heat the passenger cabin sufficiently. So there's a considerable, in cold weather climate, there will be a considerable improvement in efficiency with the fuel cell bus. But the other thing, other points I wanted to make, Ray had a question about the LCFS. Now, except for Sunline, which has been making their own hydrogen with electrolyzers or reformers from the get-go, AC Transit, as an example, most of their hydrogen is coming from steam reformation and delivery. And until the new LCFS regulations kicked in this year, they've not been able to take credit for that. So those numbers do not reflect net of LCFS, at least for AC Transit. I don't know, maybe the same for the others as well. And then the last thing I would make a very important point about is that the AC Transit fleet, those 13 or 12 buses that they're operating now are have fuel cells with that are now, in terms of their design technology, they are now 16 years old, 10 to 16 years old. So much of the data is catching up with this very quickly evolving technology. And I think that can be said about both battery electric as well as fuel cell electric.
Leslie, Daljit from Ballard. I just want to add to Jamie's point, actually, that the fuel cell buses are operating in Oslo. They have operated in Stockholm, and you're aware that we had fuel cell buses operating in BC Transit and Whistler, actually. The Whistler buses were tested in Chicago facility at minus 30 degrees centigrade. And the fuel cell technology has evolved over the year, and the next generation technology, which we are going to introduce in about 2-3 months, will have a free start capability from minus 35 degrees centigrade. So one of the biggest benefit fuel cell bus also brings is that during the winter months, it provides you heat for coach heating or driver cabin heating or stuff like that. You don't have to heat the fuel cells basically to start. And then, of course, the buses will operate during minus 30, minus 35 C as the time comes. Thank you.
NREL work is very important. That's why we get a lot of questions here. But due to time concern, let's maybe take one more question.
Sanjay Dayal, Electrify. Is the data, this is fantastic data, is that data you are sharing with others to raw data, which you are collecting through by?
We don't typically share the raw data, but we have published the data, and it's in multiple reports.
Okay. You said we don't typically share. Is there a way where we can partner with you? And
well, mostly it depends on the fleet. Most fleets aren't comfortable with me just handing out their raw data. So, I mean, it would depend on whether the fleet was comfortable with that.
Thank you.
Hi, Leslie.
Hello.
David Warren from New Flyer, and I want to share with you a little bit about cold weather. We have buses operating in New York City, in Manhattan on the M42 route, and that goes from the Hudson River to the East River. We have high-power chargers on each end of the route. New York City did not want an auxiliary heater. They wanted all electric. So on the M42 route, if you've been to Manhattan, it averages about 4 miles per hour. So let's do a little bit of math here. We have a 20 kilowatt heater on board, and over the past couple weeks, it's been down in 20 degrees. And so when you operate at 4 miles per hour, you're obviously stopping and opening up the front door, the rear door, and allowing a lot of heat out of the bus. So the electric heater tends to run very consistently at 20 kilowatt. If you're operating at 4 miles per hour, your energy consumption for heat alone is going to be 5 kilowatt hours per mile. The propulsion of the bus in Manhattan is only about 1.3 kilowatt hours per mile. So when we look at the total energy dissipated for that bus, we're up on the order of about 5 or 6 kilowatt hours per mile. When you do an Altoona test, you typically see results down at the 2 kilowatt hours per mile. So when you plan your bus routes, obviously California has very good weather, not typical of many states. But this electric heat, all electric heat, can be quite significant and really affect your overall charging strategy, your route planning, how much batteries you put on board. So, thank you.